From Neural Newscast, this is Model Behavior, AI-focused news and analysis on the models shaping our world.
I'm Nina Park. Welcome to Model Behavior. Model Behavior examines how artificial intelligence systems are built, deployed, and operated in real professional environments. We focus on the intersection of technical architecture and institutional impact, providing a clear perspective on the systems that are defining the future of computing and enterprise labor.
I'm Thatcher Collins. Today is May 13th, 2026, and we are tracking a major split in the industry's strategic path towards superintelligence. We are also breaking down Google's latest releases for the Android mobile ecosystem and exploring how these updates are shifting the balance of power between cloud services and local device processing.
The conversation around artificial general intelligence has reached a new inflection point, where high-level theory is meeting massive capital deployment. We are currently seeing three distinct theories on how to reach superintelligence. Sam Altman at OpenAI maintains that we have already crossed the event horizon, focusing on scaling transformers and adding reasoning layers to ship autonomous agents. However, Yann LeCun has taken a radically different stance, recently leaving Meta to lead AMI Labs.
That move by LeCun is significant because of the volume of capital involved, Nina. He raised $1.03 billion in what is being called the largest seed round in European startup history. His thesis is blunt. He claims that the industry's reliance on large language models for superintelligence is, in his words, complete bullshit. He is betting $1 billion that next token prediction will never reach a true understanding of physical reality.
LeCun is championing world models instead of traditional large language models. This approach seeks to give AI a sense of physical reality and causal reasoning that is not dependent on textual probability. Meanwhile, we have a third major player, DeepSeek, arguing that neither scale nor architecture is the primary bottleneck. They are leaning heavily into pure reinforcement learning, which involves training models to think through complex strategies without being shown examples of good answers first.
I have to push back a bit on the immediate feasibility of that world model approach, Nina. While LeCun has the pedigree, we have not seen a world model outperform a scaled transformer in a production environment yet. DeepSeek's approach is interesting because it mimics human strategic development, but the compute costs for reinforcement learning at that scale are still largely theoretical for the average enterprise looking to deploy today.
The tension between these three schools of thought is what makes today's landscape so volatile. It isn't just a race of speed, it's a race involving fundamental physics and logic. But while the major labs argue over the distant horizon, Google is shipping concrete updates to the mobile experience right now. Specifically, they are integrating Gemini 3.1 directly into Chrome for Android to change how we interact with the web.
This marks a transition from a simple mobile browser to what Google calls an AI-powered browsing assistant. The most notable addition in this version is Auto Browse. It is an agentic system designed to handle repetitive tasks like reserving parking spots, updating online orders, or managing monthly subscriptions without the agent having to navigate through multiple submenus or complex web forms manually.
Beyond automation, there is a visual component called Nano Banana. This integration allows users to perform AI-powered image customization directly within the browser interface. For instance, if you are looking at an apartment listing, you can virtually redesign the room or generate infographics from the text on the page. It seems Google is trying to bridge the gap between static text analysis and dynamic visual creation.
Nina, we should address the fragmentation problem here. Google is limiting many of these Gemini intelligence features to premium hardware, like the Galaxy S26 and other flagship devices. This leaves a significant portion of the Android user base behind. If AI is the new foundational layer of the operating system, but you need a €1,000 phone to access basic productivity tools, we are looking at a growing digital divide.
That is a fair point, Thatcher. However, Google is also updating the Gboard keyboard with a feature called Rambler. It is a real-time automatic editor that filters out hesitations and corrections during voice dictation. If you say a filler word or correct yourself mid-sentence, Rambler cleans the text on the fly. It is a subtle but very practical application of reasoning models running at the edge of the network.
The Create My Widget tool is also worth mentioning today. It uses a simple text prompt to generate custom interface elements for your home screen. If you want a widget that specifically tracks local pollen levels and sports scores simultaneously, the AI builds it for you. But again, this requires local processing power that mid-range chips simply do not have yet. It raises questions about whether these tools are truly ready for mass adoption.
Moving from the operating system to the models themselves, we have to look at the internal competition between Gemini 3.1 Pro and the new Gemma 4. Google essentially released Gemma 4 as a free, open-source alternative for the community. For many developers, the question now is whether they should keep paying the $20 monthly subscription for Gemini Pro when Gemma 4 is available for free.
The performance delta is actually quite specific. In reasoning benchmarks, Gemma 4 is surprisingly strong, scoring 89% on complex math reasoning. That is a massive jump from previous versions. However, the speed gap is where the premium version justifies its cost. In a timed test, Gemini 3.1 Pro answered a complex prompt in 8 seconds, while Gemma 4 took over 5 minutes via the AI Studio platform.
Speed isn't the only factor. The context window remains a major differentiator. Gemini 3.1 Pro can handle roughly 1,500 pages of text in a single conversation. That allows for deep research across entire codebases or multiple books at once. Gemma 4, while capable, has a significantly smaller window, making it less ideal for large-scale enterprise documentation and long-form technical analysis.
But we should not overlook the privacy advantage of Gemma, Nina. Because Gemma 4 is open source, it can run entirely offline on local hardware. For professionals handling sensitive client data, the ability to have a high-performing model that never sends a single byte to a cloud server is a massive selling point. You simply cannot get that level of data sovereignty with the cloud-based Gemini Pro service.
It seems the choice depends on whether you value the integrated Google ecosystem and deep research features or local control and cost efficiency. Both models show that Google is successfully bifurcating their strategy to capture both the enterprise cloud and the local developer markets, ensuring they remain a central player regardless of how a company chooses to deploy their intelligence.
Exactly. Whether it is the pursuit of LeCun's billion-dollar world models or the utility of Google's new browser agents, the theme of 2026 is moving away from simple chat and toward deep integration and specialized reasoning. It is a fundamental shift in how we conceive of AI capabilities.
Thank you for listening to Model Behavior, a Neural Newscast editorial segment. mb.neuralnewscast.com. Neural Newscast is AI-assisted, human-reviewed. View our AI transparency policy at neuralnewscast.com.
This has been Model Behavior on Neural Newscast, examining the systems behind the story